Hello everyone, it's Qichao Ying from Fudan University. Today I want to present our new paper called Bootstrapping Multi-View Representation for Fake News Detection. It's a joint work by Fudan University, Shanghai University, and the Chinese Academy of Sciences. Previous researches on multimedia fake news detection includes a series of complex feature extraction and a fusion network to gather useful information from the news. However, there are certain drawbacks. First, they use textual and visual features as integrated representation, but the disentanglement of features from different views has not been thoroughly investigated. In many cases, the models are at a black box level in which the network design cannot explicitly highlight the most contributive components. Besides, many recent works solely rely on cross-model correlation. For example, these methods don't know how semantic meaning of the image should align with the text in order to generate fused feature. But we argue that cross-model correlation do not necessarily play a critical role in fake news detection. This figure provides an example where we can see that both fake and real news more or less contain cross-model correlation. Therefore, clarifying the role of both new model and cross-model feature is vital for improving fake news detection. Our main contribution is that we propose a novel fake news detection scheme of generating multi-view representations. We understand their individual importance and optimize the fused features. Besides, our method not only outperforms state-of-the-art multimodal fake news detection schemes on several popular datasets, but also provides a mechanism for interpreting the contribution of different representations. Given a multimodal news, we first extract representations respectively from the views of the text, the image pattern, and the image semantics. And we further propose improved multi-gate mixture of expert networks, denoted as IMMOE, for feature refinement and fusion. Then, representations from each view are separately used to causally predict the fidelity of the whole news. And the prediction scores are used for adaptive feature reweighting. Then we use cross-model consistency learning to implicitly guide multimodal representation refinement. And the importance is that we explicitly disentangle correlation from other cross-model information by introducing an independent representation. Finally, we bootstrap multi-view features for refined fake news detection. For cross-model consistency learning and multimodal feature generation, we first train our model to predict whether a given text and image pair matches, which is quite similar to previous methods. We arbitrarily combine images and text from different real news. The task can be in parallel trained with the main task of fake news detection. However, the difference is that we consider that multimodal features should not merely represent cross-modal correlation. There are also many other factors. For example, multimodal joint distribution, emotional difference, etc. They can help decide whether the news is fake. So, as shown in the right figure, we explicitly disentangle correlation from other cross-model information by letting the inferred cross-model correlation score reweight an independent trainable token that represents cross-model relevance. We do not separate, compared to previous works, we separate the cross-model learning uh, with the uh, with the detection stage, and we do not reweight both unimodal and multimodal representations by the correlation score. Experimental results show promising performance on several famous datasets, such as Weibo Gossip Cop and Weibo 21st. The left figure shows the Disney visualization results. From the figure, we see that if two news are labeled the same, their bootstrapped feature show high similarity. Otherwise, they show low similarity. It suggests the ultimate classifier has a large margin, where samples are far away from the separating hyperplane. Also, our method requires less parameters compared to previous methods. Finally, we conduct extensive ablation studies. We find that if we feed BMR with different combination of views, we find that if we bootstrap 3 multi-view unimodal representations without introducing the fusion branch, the average accuracy is 88.6%, which is more than 3% worse than our BMR method. Then we test the case of adding no constraint to the generation of multi-view representation, which results in a performance drop of 2.3%. Besides, if we do not explicitly reweight the representation according to the subtasks, the accuracy drops will decrease by nearly 3%, indicating that there would be misleading information if we do not weight the representations. Thanks for the listening.